Alright, this is page 1 of Chapter 6A Review Worksheet 1. And looking at number 1 here, I'm can break this out. You know, I can put quotients together or break them apart. And I'm going to break this out into the fourth root of, I know that 16, that's 2 to the fourth and an x to the fourth. And 81 happens to be 3 to the fourth. And then I've got, y to the 8th. So in the numerator, a 2 will come out and an x will come out. And in the denominator, a 3 will come out and a y to the 8 divided by 4, or y squared, will come out. So everything completely rationalizes. For number 2, it's a similar thing here. I'm going to rewrite this because, well, I think the first thing I'm going to do is simplify I notice how I've got x's, y's, and z's in both numerator and denominator of this quotient. And so I'm going to simplify that. At the same time, I'm going to write, so negative 1/25, that's negative 5 to the third. And this is the 8 is 2 to the third in the denominator. And then I've got x to the 5th over x squared, so I'm going to simplify that. So an x to the third in the numerator. I've got y to the 4th over y to the 10th, which leaves a y to the 10 minus 4, or 6th in the denominator. And z to the 7th over z to the 4th leaves a z to the 7 minus 4, or 3 in the numerator. So now, looks like everything's going to rationalize here. I'm going to have in the numerator, a negative 5 comes out, an x, and a z. And in the denominator, a 2, and then a y to the 6 divided by 3, a y squared comes out. So that's that. For number 3, I'm multiplying together 2 square roots. So this is going to be a 3 times a 2 as the rational parts get multiplied together. And then for the 15 times the 75, I'm not going to multiply those together to get a big number. I'm going to break them apart. So this is going to be a 5 times 3 for the 15, and then this is 3 times 25, or 3 times, 5 times 5, or 5 squared. So I'll have a 3 squared, so a 3 will come out, and a 5 squared, so a 5 will come out, and this 5 will stay in. So now I've got that 6 from before, and I'm going to be multiplying it by a 3 and a 5 that came out times the square root of 5. So we get 90 times the square root of 5. Okay, number 4 is quite easy. It's the square root of n to the 1 times n to the 9. I'm multiplying powers with the same base, so I add those exponents. So it's the square root of n to the 10th, and that's a little invisible 2 there. So this is n to the 5th power. Number 5, kind of similar to number 3. I've got square roots. I'm going to multiply those square roots together. 7 times 63, I'm going to view the 63 as 7 times 9. So I've got some perfect squares there, because 9 is 3 times 3. And then m to the 7 plus 5 is m to the 12th. So a 7 will come out, and actually the square root of 9, a 3 will come out, and m to the 12 divided by 2, m to the 6th comes out, so I get 21 m to the 6th. So, oops, that's that page. Moving on to number 6. So there's a number of ways I can do this. I'm going to go ahead and simplify that denominator first. This is 2 times 9, so I'll have a 3 come out and a 2 stay in. So now to rationalize, I can multiply by 1 in the form of root 2 over root 2. And I can cancel those 3's, 3 over 3. So I'm going to get square root of 2 over square root of 2 times square root of 2, which is 2. And I'm done. See, number 7, I'm multiplying 2 fractions together under the radical. So I'm going to simplify the 2 over 4, cross-canceling here is a 1 over 2. So I get the square root of 3 over 14, the square root of 3 over the square root of 14. There's nothing I can take out of the square root of 14 to simplify it, so I just have to rationalize that denominator, multiplying by 1 in the form of root 14 over root 14. So I get a rational 14 in the denominator, and then 3, this is 2 times 3 times 7 under here. So, oh, I'm sorry, it's just 2 times 7. So anyway, I've just got square root of 3 times 14, which is 42 in the numerator. Okay, number 8 is an example of using the quotient property to take the quotient of two roots and put it together under one root, because it can be simplified to think of it like this, because 5 goes evenly into 320. So this would be the cubic root of 320 divided by 5, which is 64. So I've got the cubic root of 64, which is just a rational 4. Number 9 is a good one because we've got a cube root, not a square root in the denominator. So I could think of that as the cubic root of 25 as, I always think of things in their lowest base as an exponential term. So the 25 is a 5 squared. And if I want to get a rational 5 out in the denominator, I need to be able to get a cubic root of 5 to the third power in the denominator, so I can just pull out a 5. So the missing factor here, and what I want to multiply the cubic root of 5 squared by, is the cubic root of 1 more power of 5, 5 to the 1. And that gets me the cubic root of 5 to the third, which is a 5. So I have to take that to the numerator too. So 10 times the cubic root of 5 is like so. And then I've got a 10 over a 5. So final answer is 2 times the cubic root of 5. Kind of similar with number 10. I can put these back together and simplify the y's at the same time. So this is the square root of 50 divided by 2, which is, well, I can look at it all under one root like this. And simplify the y to the third over y to the eighth. We'll leave a y to the fifth down here. So this would be a square root of 25 in the numerator over the square root of y to the fifth. Now, instead of simplifying this, I just need an even power of y to be able to get a perfect square. So if I want to get a y to the sixth, the square root of y to the sixth, to get a y out in that denominator, I'm sorry, a y to the third, because that's a 2, I need 1 more power of y, just a square root of y to the first. So I multiply by 1 in the form of y over root y here. And I get the square root of 25y, so 5 times the square root of y all over y to the third. Okay, number 11, let's see, let's simplify this together first. I have, 3 is a common factor of 6 and 27, so this is 2 3's and 9 3's. And then m squared over m to the 7th leaves an m to the 5th in the denominator. So I've got the square root of 2 over the square root of 9m to the 5th. I'm going to break that down as m to the 4th times m to the 1st. So square root of 2 over, I'll have a 3 come out from the 9. And an m squared will come out, and then I'm left with the square root of m. So I guess as a last step here, I want to rationalize that denominator. So multiplying by 1 in the form of square root of m over square root of m. I will get one more, root m times root m is one more power of m. So the denominator is going to go to 3m to the third power, and then I'll have the square root of 2m in my numerator. Okay, continuing on. Okay, this is addition and subtraction. Now, to add and subtract radical terms, I need to simplify each one first and see if they're like terms or like radicals. So I know I have, this is a 3 times a 25, so dealing with square roots, the square root of that 25 is going to come out as a 5 and multiply by that negative 3 CD. So I'll have a negative 15 CD times the square root of the 3 and the c stayed in, plus. Now here, this is a perfect square of a 4 times a 3, so a 2 will come out and multiply by that 2 on the outside, and then a c will come out and a d will come out. So I'm going to have 4 on the outside, the 2 times the 2, times the square root of this 3 that stayed in, and oops, this was a c to the third, so let's rewrite that, c to the third, that I had a c squared and a c, so a c does come out, so that's there, and a c stays in. Uh-oh, I messed that one up. Darn it. I wonder if I could rewind this at all.
That was a huge one if you published a minute.
What?
That was a huge one because it went on for like 5, 6, 7 minutes.
Well, this is a big one. This is going to go on a lot longer when I'm done. I just made a mistake.
It's horrible to plug up in the middle like that.
It's horrible?
Oh, you gotta redo the whole thing.
No, I don't. I paused it.
Oh, you can't do that?
Yeah, and I'm just redoing it now.
Oh, good. Didn't make you do that.
Okay, redo on that problem. So we had 3 times 25. So a 5 will come out and a 3 will stay in. That 5 is going to multiply by the negative 3 CD. So negative 15 CD times the square root of a 3c that stays in. Now this was a c to the third. So let's do this right. 4 times 3. So a 2 comes out and multiplies by the 2 in front. So I'll have a 4. The 3 will stay in. That c to the third breaks down to c squared times c to the first. So a c will come out and a c to the first will stay in. And the d squared will bring a d out. So this will be, what's left in is a 3c. And then I look at this and I ask myself if I've got like terms, and I do, because everything after the coefficient of negative 15, which is cd times the square root of 3c, is the same as everything to the right of the 4 over here, cd times the square root of 3c. So when I have negative 15 of something plus 4 of something, I have negative 11 of that something. So I get negative 11 cd times the square root of 3c. Number 13 is, this means that this binomial is a repeated factor, is a factor 2 times. So you can just multiply it with distributive property. It's very handy to know the pattern. So it's going to be the first term squared, so root 10 times root 10 is 10, minus twice the product of those two, so minus 4 times root 50, and then minus 4 times root 50 again, plus 4 root 5 times 4 root 5. So again, I get 16 times 5, which is 80. So 10 and 80 is 90, minus 8 root 50, and that 50 is 2 times 25, so a 5 will come out and multiply by the 8. So my final answer will be 90 minus, and this 2 stays in, 40 times the square root of 2. And then last problem on this side of the page, number 14, I've got 2 root 5 plus root 2 over root 10. Nothing I can simplify. These aren't like terms in the numerator, so I'm just going to multiply by a big 1, the whole thing in the form of root 10 over root 10 to rationalize the denominator. I need to distribute that in the numerator. So in the denominator, I'll have a rational 10. So 2 times the square root of 5 times the square root of 10, before simplifying, is just 2 times the square root of 50, plus root 2 times root 10 is square root of 20. So with the 50, this is 25 times 2, so a 5 will come out and multiply by the 2 in front, so I'll get 10 times the square root of 2, and then this is 4 times 5, so a 2 will come out to the front, and the 5 will stay in, and this is all over 10. And then you have to ask yourself if you can simplify it anymore, and what you're looking at is just the rational parts. You have a rational 10, a rational 2 as terms in the numerator, and a rational 10, so you're looking for a common factor, and that would be a 2. So if you factor a 2 out of the numerator, you've got 5 root 2 plus root 5, and of course 10 is just 2 times 5, so we can cancel right here, and the final simplified answer is 5 root 2 plus the square root of 5 all over 5. And you can't cancel these two 5s at all because it's not a common factor. There's no rational 5 in that last part. So that's it for page 1 of the worksheet.